Welcome back. Let's reading a bit more. I was just to make some video on my language Danish about jet engines. So I need to finish this. Then I will drive American Truck Simulator later today. So I need half a minute to get to my bed. I got up like 1.5 hours ago, so I'm still sleeping. So I need half a minute. I need to check my cell phone one more time. I got my YouTube money today. So nothing on my cell phone.
Powerjets W.2. The Powerjets W.2 was a British turbojet engine designed by Frank Whittle and Powerjets Research and Development Limited. Like the earlier Powerjets W.1, the reverse flow combustion configuration included a double-sided centrifugal compressor, 10 combustion chambers and an axial flow turbine with air-cooled disc. It entered production as the Rolls-Royce Welland and was the first UK jet engine to power operational aircraft, the Gloucester Meteor. Design and Development, edit. In 1940 the Air Ministry placed a contract with the Gloucester Aircraft Company for prototypes of a new twin-engine jet fighter aircraft to the requirement of F.9/40. This aircraft became the Gloucester Meteor. At the same time, Powerjets was authorized to design a new engine that was intended to power the same aircraft. The W.2 was built under contract by the Rover Car Company in the early 1940s. Relations between Powerjets and Rover were somewhat strained and development of the W.2 was very slow. In late 1942, Rover agreed to exchange their jet engine factory at Barnoldswick, Lancashire for the Rolls-Royce Meteor tank engine factory in Nottingham, with no money changing hands. At the behest of the UK government, Rolls-Royce thereupon assumed control of the W.2 project, with Frank Whittle and his small team at Powerjets acting in an advisory capacity. Together, they ironed out the problems with the W.2 and finally put the engine into mass production as the 1,600 pounds force, 7.1 kN, thrust Rolls-Royce Welland. These engines were installed in the Gloucester Meteor FMK1 and early FMK3s and entered service in 1944. After initial suggestions in 1939 by the Engine Department of the Royal Aircraft Establishment, RAE, the latter's pie-stock section experimented with the technique of injecting fuel into the engine's exhaust nozzle, later known as reheat, and this technique was further refined after Powerjets and the personnel from pie-stock had been amalgamated. Reheat was later flight trialed in the W.2/700 engines in a Meteor I. The technique increased the Meteor's speed by 30 to 40 miles per hour. Variants, edit. The Rover designations for engines produced at Barnoldswick were given a B prefix together with their own internal design number, for example, B.23. Later, after designs were transferred to Rolls-Royce, RR, an additional R was prefixed, changing the designation to RB to prevent possible confusion with US bomber designations, for example, RB.23. This RB designation system continues to be used within Rolls-Royce to this day. W.2. Design thrust of 1,600 pounds force, 7.1 kN, and a dry weight of approximately 850 pounds, 390 kilograms. Early versions could not exceed 1,000 lbf thrust without compressor surge and excessive exhaust gas temperature. Engines produced by Rover under subcontract to MAP. W.2 design quickly abandoned and replaced by W.2B after Whittle re-evaluated W.2 design and calculated exhaust gas velocity would approach Mach 1. W.2 Mark IV. W.2 manufactured by British Thomson Houston, BTH, but discovered to be sensitive to design assumptions, so changed in stages by power jets to bring in line with W.2B design. Wrecked by bursting of faulty new impeller forging on the 10th of October, 1941 after completing a useful amount of testing. W.2Y. Direct flow straight-through combustion chamber design, May 1940, not built. W.2B/Rover B.23. Initial first two engines produced by Rover as the B.23 with one installed in E.28/39W4046/G, other units built by BTH, and power jets. Initially engines suffered failure of Rex 78 turbine blades, General Electric, GE, in the US sending Rover several improved sets of Hayes alloy B blades in July 1942. Blade material later switched to pneumonic 80. Engine design later transferred to Rolls-Royce as prototype of the B.23 Welland, and also built in US as GEIA redesigned B.23 combustion chambers for this engine designed by Joseph Lucas Limited. W.2B Mark II. MAP authorized Rover redesign using 10-vane diffuser designed by Rover /RR, and new turbine with fewer, broader blades. By December 1941 giving 1,510 pounds force, 6.7 kN, without surging. W.2B/500, Rover B.26. W.2B with longer turbine blades and using diffuser of W.2B Mark II and new blower case and turbine design to give 1,850 pounds force, 8.2 kN, at 16,750 rpm. First run in September 1942 attaining 1,755 pounds force, 7.81 kN. SFC, 1.13 pound/hour lbf, with jet pipe temperature of 606 degrees Celsius. Initially suffered from resonance at 14,000 rpm leading to impeller blade cracking. MAP authorized redesign with straight-through combustion chambers by Adrian Lombard and John Herriot, the latter of the aid, at Rover as the B.26 with 4 test engines being built before design taken over by RR and after redesign for greater airflow becoming the B.37 Derwent. B.26 combustion chambers designed by Joseph Lucas Limited. W.2/700. New Type 16 compressor diffuser, new compressor casing, plus improved compressor rotor sent over from GE, all combined to produce 80% compressor efficiency, pneumonic 80 turbine blades, and a static thrust of 2,000 pounds force, 8.9 kN, at 16,700 rpm. By 1944 producing 2,485 pounds force, 11.05 kN, at a pressure ratio of 4:1 with airflow of 47.15 pound /s from same size engine as W.1. SFC, 1.05 pound /hour lbf, with jet pipe temperature of 647 degrees Celsius. Flight tested reheat in Meteor IE215/G increasing top speed from 420 miles per hour to 460 miles per hour. Flight tested to 505 miles per hour at 30,000 feet in E.28/39W 4046/G. Also ground tested with aft ducted fan. W.2/800. W.2/700 with longer turbine blades for greater thrust. Suffered from turbine blade failure. W.2/850. A developed version of greater thrust of 2,485 pounds force, 11.05 kN, at 16,500 RPM and a higher dry weight of 950 pounds, 430 kilograms. Rolls-Royce B.23 Welland. Mass-produced version of the W.2B/Rover B.23 for Meteor I developed 1,600 pounds force, 7.1 kN, static thrust. SFC, 1.12 pound/hour lbf. 100 produced. Uprated to 1,700 pounds force, 7.6 kN. Thrust with nozzle inserts for chasing V1S. Type tested to 500 hours, into service for Meteor I at 150 hours time between overhaul, TBO. Rolls-Royce B.37 Derwent. Combined design based on W.2B/500 and Rover B.26 for Meteor 3. Straight-through development of the trombone-style W.2 configuration, using already tooled-up compressor casing for Welland, new RR diffuser, and with compressor and turbine air and gas flow increased by 25% to give 2,000 pounds force, 8.9 kN, static thrust. First tested July 1943. Type tested to 500 hours. Into service for Meteor 3 at 150 hours TBO. Applications, edit. The following aircraft were used for test purposes only. 1 Gloucester E.28/39. 2 F.9/40. 3 Vickers Wellington. The W.2B/700 was to be used in the Miles M.52 supersonic research aircraft. In order to achieve the thrust required for supersonic flight, a version of the engine was developed using a turbine-driven augmenter ducted fan, an early form of turbofan. The No.4 augmenter was mounted behind the engine, drawing fresh air through ducts surrounding the engine. Power was boosted even further by supplying the air to the world's first reheat jet pipe or afterburner, which was actually a very early athodid or ramjet. The hope was that this combination of the W.2/700, turbofan augmenter and reheat/ramjet would produce the required power for the proposed 1,000 miles per hour aircraft. Engines on display, edit. 1 A preserved W.2/700 is on public display at the Farnborough Air Sciences Trust. 2 Another W.2/700 is part of the Aero Engine Collection at Royal Air Force Museum, Cosford. 3 A W.2/700 is on display at Cranfield University. Awarded Engineering Heritage Award No. 102. 4 A section W.2/700 at Lutterworth Museum. 5 W.2/500 at RAF Museum, London. 6 A Rover W.2B/26 is on display at the Midland Air Museum. Specifications, W.2/850, edit. Data from Janes. General characteristics. 1 Type, centrifugal flow turbojet. 2 Length. 3 Diameter. 4 Dry weight, 950 pound, 431 kilograms. Components. 1 Compressor, single-stage double-sided centrifugal flow. 2 combustors, 10 reverse flow. 3 turbine, single-stage axial flow. 4 fuel type, kerosene. Performance. 1 maximum thrust, 2,485 lbf, 1,127 kgf, at 16,500 rpm. 2 overall pressure ratio, 4:1. 3 air mass flow, 47 pound /s, 21 kilogram /s. 4 fuel consumption, 2,610 pound /hour, 1,185 kilogram /hour. 5 thrust to weight ratio, 2.6. See also, edit. Related development. 1 Power Jets W.1. 2 General Electric IA. 3 Rolls-Royce Welland. Related lists. 1 List of aircraft engines. References, edit.